Hi, now we're going to talk a little bit about frequency and wavelengths. And I know you're looking at this, and for some of you who maybe didn't do so well in math, before you start hyperventilating, let me assure you it's pretty simple. I'm writing this using official symbols and whatnot, so you can see how it's supposed to be. But let's just hang on a second. We'll talk through this, and we'll see just how simple this is. I'm not going to go in depth on the electrical theory. Read your textbooks. There's a lot of information on that. Get on the internet. You can really understand these concepts. But I'm going to give you the real basics of what you need to know for your technician class exam. First of all, let's talk about wavelength. Well, wavelength is one complete cycle of an alternating current. You've probably seen this symbol before. This would represent one wavelength from here to here. So when we talk about wavelength, the key part of the word being length, we're talking about how long does it take for one complete cycle. And we measure that in hertz, which is abbreviated as Hz, hertz. This is all based on metric. So with hertz, we'll have kilohertz or megahertz. You've heard of megahertz, I'm sure. And so hertz is our base unit. We often talk in kilohertz or megahertz in amateur radio. So let's try to figure out what the frequency is if we know the wavelength. Now the frequency is going to be how many cycles per second. So how many of these wavelengths do we have per second? That's how many cycles. That's our frequency. How frequent does it happen? We have two equations, and they're both inversions of each other. Frequency equals 300 over wavelength. So if you want to know what the frequency is, and you know the wavelength, you just plug the wavelength into there and divide 300 by that number. That will tell you what the frequency is. The wavelength will tell you 300. The wavelength you can find out if you know the frequency. Okay? Now let's remember something. Wavelength, when we're using the equation, and all this is the Greek letter lambda. That's what they use for wavelength. Wavelength is, I shouldn't say equal to. For wavelength, we always have it in meters. Okay, that's how the equation works. The equation always has to be done in meters. So you have to plug a number in here that's in meters. Frequency, we always know in megahertz. And I'm going to use the symbol there for megahertz. Megahertz. So if we plug a number in here, it has to be the megahertz. It can't be the hertz. It has to be megahertz. And we can talk a little later about the conversions, like how to convert things or whatnot. Well, let's start with something simple. Okay, how about we try to figure out what the wavelength is? All right, here we are on the HF radio, the high frequency radio. And we have a frequency here that's dialed up there, 14.240 megahertz. All right, this is the megahertz, and this is the kilohertz. So 14.240 megahertz. Well, how are we going to figure that out? Well, we know the frequency, and it's in megahertz, right? It's already in megahertz. So if I want to find wavelength, I'm going to go 300 divided by what? 14.24. We take our little calculator, and yes, you can take a calculator to the exam. 300 divided by 14.24. Just make sure your calculator doesn't have advanced memory or isn't a scientific calculator. They might not let you use that. The answer is 21.06. Now, because this is a rough equation, 21.06, you're going to have multiple choice answers on your test. So if this were one of the test questions, you would probably have, let's say you would have 40 meters, 20 meters, 10 meters. Let's say those were three of your options. Well, out of those three options, which one do you think it is? Well, the closest one is 20. That's right. That is on the 20 meter band. So 20 meters is the frequency. That's what we refer to the bands as. So the frequency means it's 20 meters long. And this here is wavelength, not hertz. So 20 meters. So that means it takes 20 meters for one complete cycle. And that means it's happening at 14,240,000 cycles per second. That's how fast that many cycles are occurring. So frequency and wavelength. And we can look at the opposite of this too. We could say, okay, if you're on 20 meters, what frequency range are you looking at? Well, let's do something more that's going to be like technician class. Let's say we're on 2 meters. Okay, so if we're on 2 meters and we want to know the wavelength, or we want to know the frequency, well, frequency equals, up here, right, 300 over 2 meters, right? Well, that one we can do in our head. That's 150, right? So the frequency is going to be 150 what? Well, we know that these equations have to be in meters and megahertz. And since we're talking about frequency, it's going to be megahertz. Frequency equals, remember, we divided by 2 meters, so now we're going to have 150 megahertz. Well, looky here, 145 megahertz. This radio is sitting on the 2 meter band right now. So that's how you can figure out the frequency, and it's also how you can figure out the wavelength. You just use these equations, and I encourage you to learn these equations because then you don't just have to memorize those questions. What you can do is you can just know it's 300 over frequency or 300 over wavelength, and you can just plug the numbers in and you can do the math yourself. And when we come back, we'll take a little bit of a look at some of the conversions between megahertz and kilohertz and meters and centimeters and things like that. So stay tuned.